Hello students, welcome to session. In this session, I will discuss the concept based on DFA, that is deterministic finite automata. Okay, the finite automata are called deterministic finite automata if from the given input string it reads one unique symbol at a time. Okay, listen, read this statement carefully. That from the given input string, suppose the string is given like a, okay, and then if it reads one unique symbol at a time, when when it will do the transition from one state to another state, at that time it should have only one input symbol, then it is called deterministic finite automata. Okay, I know that right now it's not clear to you, but have a patience, by the end of the video it will be clear to you. So let's we come back to the definition first, that what is the definition of DFA. So definition of DFA is that DFA is a collection, or you can say that DFA is the set of five tuples. Okay, set of five tuples. What are they? What are they? That these are capital Q, okay, then sigma, then delta, then Q naught, then QF. Okay, either you can use Q of F or you can use capital F. In place of that, you can also use capital F. Both have the same meaning, that is final state. Okay, so what is Q here? Q is the set of states. What is the sigma here? Sigma here is the set of input symbols. Then what is a del here? Del is transition function. Okay, then what is Q naught? Q naught is the initial state, and QF is the final state. So this is the description of the tuples which were given in this. Now, what do you mean by this states? What does this state means? See, whenever you give input, okay, then those inputs will switch from one state to another state. Okay, so before that, let me explain you that how you represent the state. So see, there is a circle, and if the circle is initiated by a single arrow, this is the representation of initial state. Okay, now if there are two circles, then this is the initial state, and from this state, if the particular input is moving from this circle to this circle, then you can say that this is the state 1 and this is the state 2. Okay, from the input, as we have mentioned, there is Q naught which is called initial state. So since this is the initial state, we represent it in the form of Q naught. After that, there are many intermediate states. Okay, and by the end there is a final state. So if there is a double circle inside circle, in this form, if particular state is defined, then it is called final state. Okay, and if in this, suppose you want to repeat some set of elements for a number of time, then you can keep the loop in the form of this in that particular state. Okay, so this is basic awareness regarding the presentation of transition diagram. Okay, now let we come back to this definition. So how we represent the states? We represent the states in the form like q naught, q1 up to the states we want. Okay, I'll repeat the same. We will represent it in the form of q naught is the initial state, q1, q2 up to qn as the requirement of the transition diagram. In this, q naught will be represented as initial state, qn or q of f is called final state, and among this, if the elements or the input symbols which are moving from one state to another state, okay, at that time whatever the symbols we will mention here, whatever the symbols we are going to mention here, they are called, these are called symbols. Okay, then what is the transition function? So now let me discuss this concept also, that transition function is nothing but just the transition of or the movement of symbols from one state to another state. How we explain that? See, transition function del is represented as q naught cross sigma equal to q. Okay, q cross sigma equal to q is the transition function. What does it mean? It means that from particular state, by giving a particular input may be 0 or 1 or a, by giving particular input symbol, in which state it will move. Okay, this is called transition function. So as we move, as we when we will do some examples, at that time you will come to know that what does this del function represents. Q represents a state, sigma represents symbol, and from which state, by taking which input symbol, at which state it reach, this is called transition. Okay, or the function which involves in this is called transition function. So this is the description of the tuples. Okay, now let me brief you about the DFA once again, that DFA is the deterministic finite automata. It refers the, it reads one unique symbol at a time. Okay, along with that, it does not support, it does not support null move. Null move means empty move. Okay, when you will do the NFA, at that time you will come to know the difference between what is a null move and what is that without that, why the DFA is not supporting null move. Okay, and one point is DFA support multiple final state, multiple final states. So these are the 2 points which you have to be note, and one point is this, that it supports only, it reads one unique symbol at a time, and it does not support null move, and it supports multiple final states. Okay, so this is the basic concept of DFA. Now let me do the example so that it will be easy for you to understand that what does this says. Okay, suppose you want, suppose you want to print, you want to pass the string which contains at least at least one pair of 1 0 in the string. Okay, means you want to prepare a deterministic finite automata through which it supports the string which starts with any element with any number of element but has one pair of 1 0 and either end with 1 0 or have any number of elements after 1 0. Okay, so you have to prepare the one DFA for that. So how you will prepare? See, there is an initial stage Q naught. From here you will give the input. Okay, so suppose if you want to give 0, suppose string will be like 0 1 0 or 0 0 1 0 or 1 1 0 or okay, or you can say that there is a string like 1 1 0 1 1 0, so and 0 0 0 1 0 0 1 1 1 0. So in all the strings you come to know that there is a one pair of 1 0 is available in this also, in this string also, in this string also, in this string also there is a 1 0, in this string also there is a 1 0. So at least 1 0 is available in all the strings. So this we have to create the DFA which supports such kind of input values. So for that what we do, for that we have prepared one of the finite we are going to prepare one finite automata. In this, suppose there is a state q naught. At that time we have given one input in the form of 0, and after that means it means that whenever we get a 0 in the beginning we will be in the initial state, and whenever we get 1 we will change the state and we will reach to some other state that is q1. Okay, and after that if we get n number of ones then we'll make a loop on it. After that if we get a 0 then we have to end the string, so we have represented it by q naught, q of f. Okay, then after that if there is n number of zeros or 1 then we will represent it like this. Okay, so this is the deterministic finite automata for the string which contains at least one pair of 1 0. Okay, I think this much is clear to all. If not, let me repeat the concept that suppose what you want to print, you want to print at least one pair of 1 0. So suppose there is a q naught, even it will support 1 0 also. Okay, q naught, q1, qf. So what does this on finite automata express? From q naught to q1 you have passed 1, from q1 to qf you have passed 0. Okay, now if there is any number of elements which starts with 0 then for that you put the loop, and after 1 if there is continuous 1 for that you put 1. Okay, after that if you want to print any value which end with 0 then it will get print, and after that if there is any number of combination of 1 or 0 then you can type it here. Okay, now let's check what are the possible inputs we are getting from this. Suppose you want to have pass the string like 0010, so from here you passed 0 0 0, so you have passed three zeros. After that you want to pass 1 and then 0, so the 1 and 0. So since we reach to the final state it means 0010 is accepted by this automata. Okay, now let's we check another, that is 11 0 1 0. Let me check for this string. So suppose we have passed here from input we have given the 1, and again we need one more 1, then 0, then 1 1 0, means yeah this is accepted by the finite automata. Okay, so we will keep this also that this is accepted by this. Then again now next string is our next string is 01110. So let's we check for that. From here we have passed the string 0, then triple one. So first time 1, second time 1, third time 1. Then we have passed the 0. Means yeah, this is also accepted by the given automata. Now let's we check 2 or 3 more strings. First is 0010. Let's we check this. So for this 0 0 1 0, yeah, this is also accepted by this automata, so we can say that yeah, this is accepted. Now we go for 110, then 1 1 0, yeah, this is also acceptable. Fine. Now let's we check for the 010. So here we have given the 0 1 0, yeah, this is also accepted by the automata which we have drawn. Okay, so from this we come to know that this automata is suitable for all those strings which contains at least one pair of 1 0 followed by any number of zeros or ones. Okay, so I think this much statement is clear to you. Now let me come to the statement, initial statement, that from the given input symbol, from the given input string, it reads one unique symbol at a time. Okay, so what does it means? So here it means is that if you see q0 is fetching either 0 or 1. Okay, similarly q1 from q1 you are either fetching 1 or fetching, or you can say that either it is initiating 1 or 0. If you talk about final state, it is also initiating either 1 or 0. Okay, there is no such state which produces same kind of inputs. Okay, like there is no such state which produces, suppose there is a q0, or you can say that suppose there is a state q1. Okay, through this state you are getting 1 which is reaching to the q2, and there is a 1 which is reaching to the q3. You will not found any such kind of inputs at particular state. Okay, so this is the thing which this statement want to express, that from the given input string it reads one unique symbol at a time. Okay, so this is what the definition of finite deterministic finite automata is. Now let's we do some more examples related to the DFA so that it will be clear to you in more better way. Okay, thank you for now.